Okay, we've got a binomial expansion and we've got a fractional power, so an infinite series, and we're going to go as far as x squared. Bit of a challenge. For me, the challenge is as much going to be fitting it on the screen, I think. So let's get started. The results that we will use for a binomial expansion with negative or fractional powers . 2 factorial, 1 times 2, and then on it goes. We'll stop at x squared and need go no further. The best advice when we're doing these is to, in the first case, we've got half of x, or x over 2 here, 1 plus x over 2, and the power is a fifth. We simply directly replace, don't do anything fancy, simply replace the x that you see in the expansion here, simply replace it with x over 2, positive x over 2, and for the power, the n that you see, simply replace that with a fifth. Try to do as little as possible in the first instance. N becomes 1/5, x becomes positive x over 2, x over 2, make sure the x and the 2 take the power, that's important. And we will get, let's sort this out, numerators, denominators. Once again, be very clear which one's which. In this you will see lots of denominators, put those all together, cancel where you can. So we've got a 2 squared, cancel with that 4 possibly. 2 squared, 4 comes a 1, and watch for your signs. So this becomes x over 10, and this becomes minus x squared over 50, and that's where we stop. We don't need the x cubed. Our next expansion is, we've got a minus x over 2 this time, and a minus 1/5. More care needed in the substitution. Once again, don't do too much, so n becomes minus 1/5, and x becomes minus x over 2. Putting this together, signs, watch for those. This one positive this time, and 25, 200, 6 over 200, 3 over 5, 6 over, what is this, 6 over 200, so 300ths. Let me put that straight away, save a bit of space. 300ths x squared, and that's where it stops. So those are my 2 expansions. Okay, not doing too badly, almost fitting it in. What we have now, range, validity. This is valid for, well, validity on the general binomial expansion is modulus of x less than 1. By modulus of x, the thing that goes into the expansion takes the powers. Now in both these cases we had positive and negative x over 2 taking the powers. So the validity for the expansions that we've created are what takes the powers, mod x over 2. That's got to be less than 1. In other words, modulus of x less than 2. That's the validity for these. And what do we have to finish off? We've got to try and expand this thing. And you would be right in thinking that it's got a lot to do with these first 2. If we create single fractions out of these things here, we will have 2 plus x over 2 to to the power 1/5. And in the green one, single fraction, 2 minus x over 2 to the power minus 1/5. And if I multiply these two things, then what I will get, the power 1/5 is going to be the numerator, and the negative power will be a denominator, both divided by 2. And so 1 divided by the other, all taking the power 1/5, negative a fifth there, will give me what I want. So I need to multiply my two series. Let me put this out of the way, see if I can sort this out. I need to multiply my two series then. So I've got my I'm losing the plot here. 1 plus x over 10 minus x squared over 50. That was my first series, and my second was 1 plus. There we go. And when we multiply these things together, what we've got to do is we've got to throw away anything that gives us powers greater than x squared. So we can get rid of a lot of these. We can see a 1 times 1, that's going to be there. Combinations that will give me x, well, I will get a 1 multiplied by x over 10 when I multiply this bracket out. And the other way around, I'll get a 1 multiplied by an x over 10 the other way. And in terms of x squareds, 1 multiplied by 3x squared over 100. And x over 10 times an x over 10, and finally a 1 times a minus x squared over 50, which is 2 lots of x squared over 100. Collect these together. 2/10, 1/5 of x, and hundredths, 4 minus 2, 2 hundredths, 1/50th x squared. So by multiplying my series, I create a new expansion, and I think, trial as it was, that is my job done.